A pulley is a wheel with a grooved or barreled rim in which you run a rope or belt. It's a simple device used to lift loads that are hard to access or too heavy to move by hand. Pulleys and multiple pulley systems are vital components of many types of machines. These pulleys are designed for use in electric motors, like fan belts in air circulation systems for office buildings, factories and mines. The factory makes its pulleys from a 50-50 mix of scrap iron and steel. The furnace heats the metal to 1370 degrees Celsius, slightly above the metal's melting point. Workers adjust the chemical composition by adding carbon and silicon. In the furnace, the metal's impurities, called slag, rise to the surface. Workers use giant paddles to skim it off. Once a sample has been analysed and passed by the lab, the molten metal is transferred by ladle to a 30-ton holding furnace. This furnace maintains the metal at a constant 1370 degrees Celsius, the required temperature for proper casting. However, metal this hot can't be shaped in a metal mould. The mould would simply melt. So instead, the factory uses damp sand. Sand withstands intense heat by absorbing it. The machine forms the moulds much in the same way a bucket forms a sandcastle. The machine first constructs the bottom half of the mould. This filter will screen out any slag particles the molten metal may still contain. Now the machine forms the top half of the mould. Workers slip a weighted metal jacket around the finished sand mould. This keeps it from collapsing under the weight of the metal. Workers fill the moulds right to the top. It takes from 30 to 45 minutes for the molten metal to solidify. The weighted metal jacket is removed. Then the mould is dumped into what's called the shakeout. The vibration breaks the sand mould apart, releasing the metal pulleys. While the pulleys go off to be cleaned, the sand is recycled into new moulds. The pulleys are in rough form. They still have to be machined to specifications. A robot places each pulley under a computerized camera. A visual recognition program guides the robot to position the pulleys in the automated tooling machines. This first machine makes the pulleys grooves. The next machine will drill holes in the hub for installing the screws. At the end of the machining process, a gauging system takes precise measurements and guides the equipment to correct any errors. This is a two-part pulley, known as a variable pulley, because it can run a belt at variable speeds. This tooling machine performs several operations on the male component. It machines the face and outside diameter on one side, then flips the pulley over to make the bore and threads on the other side. The last operation is to drill holes for the two screws that will fix the pulley to the shaft of the electric motor. A touch of lubricant and the male and female parts are assembled and finally ready to do some heavy lifting.